Hello everybody, welcome to this first training section here on EuroPython. It's a beginner to intermediate training session. It will be led as a speaker by our guest. Your name I will... Oh, okay. Okay, I feared mispronouncing your surname, so I always this... So, can you tell a bit about yourself before starting with the lesson?
Yeah, sure. I'm an R&D software engineer at Telefonica R&D. It's a telco company. Maybe you know Telefonica. I work at Barcelona, and I've been working with Python for several years. For maybe 5, no, 2 years.
You should. No?
Hello?
Can you hear me? Yeah. And not him, eh? Oh. Right.
Hello?
No, ok. Stai spento una volta. Okay. Wait a moment. Prova adesso.
Hello? Yeah.
Okay. Thanks. So he was saying that he worked in Telefonica in Barcelona. I think Telefonica is one of the biggest telephone company all around. And then you get the chance to work with Python.
Yes, since maybe 6 years, or maybe even 7 years ago. So what happened is that a lot of people in my company started moving to Python, and
Thanks to you. No.
right. And the thing is that we have some sort of knowledge community inside the company. We prepared several sessions, and here we have some of the sessions.
C'è il microfono. No, si è rispento. È spento. Mi sembra, guarda un po'. Gli ha cambiato le batterie stamattina. Sorry for the problem on the battery.
This one? Yeah, thanks. So, what we will see today here is an introduction to objects, to Python objects. We'll see what's an object. We will see the difference between mutable and immutable objects. New style classes, old style classes, data model, customization of your own classes, and a bit of objects, classes creation, meta classes, new, and so on. Okay. All the code is available here. The link is also in the EuroPython page of the talk, of the training. And the minimum requirements are Python 2.7 and nose tests. Okay. There is a requirements.txt file with few more stuff, but if you just want to run the exercises and do them, you only need this stuff. Okay. How it works. The thing is that I would like to write all the code that we are going to see today, but it's impossible to stay here for hours writing code, and most probably I will fade something. So I have this command line interpreter. The thing is that if I don't introduce any command, it takes some code that I have in the files that you have downloaded. Okay, so here you will see the code executed, and here you will see the output. Okay, this is how it works. It's important to understand. So in this case, I executed 3 prints, and here we can see the output. Okay, this is how it works. It's quite easy.
Can I ask you a question that I think every beginner sooner or later asks? Should I start with Python 2.7 or Python 3? And why?
I would say that you should try to start with 3.
Okay.
But maybe you have some dependencies, or you need some libraries that have not been ported yet.
Okay. So let's say both are good with pros and cons.
Well, if you go to Python 2, go to 2.7, which is the latest and has a lot of backports from Python 3.
I see.
Which is the good thing. But try to move to 3. And some important projects are being moved or recently have been moved. So
okay. So if you have to
at my company, we work with Python 2, 2.6 or 2.7, but I would love to work with Python 3, so it's much better.
Okay. Thanks.
Okay, so let's start. Okay. First thing, let's check the identity, the type, and the value of an instance, okay, of an object. Pretty easy, right? ID is a function, type is a function. We get the identity. Do you know what's the identity of an object? So each instance has its own identity. It cannot be changed, like the type. It's unchangeable. And right now it's implemented using the address of the object, but well, maybe in the future it changes. But for you, the thing is that it's absolutely unique inside your interpreter, okay? So what is? Any clue on what's the is? So, I check for the type. And no, the typical use of is when you want to check if something is known, okay, if it's null. In this case, we are comparing the string that I created here with another string that I created here in the same sentence, okay? And it says true, it says yeah, is. So we could say that we are testing for equality, but what we're testing is equality of the ID. Look at this other example. I have two ints. I check is, and the result is true. I check the first one, I compare the first one with 7, and the result is true. So it says they are the same. But why are the same if they are two different ints? If we compare the ID, we see that their ID is exactly the same, right? Any idea what this is happening? Somebody said, I think that somebody said the right answer. Yeah, that's it, that's it. They point to the same object. That's the answer. We have two labels here pointing exactly to the same object. What's this object? This object is an int with value 7. And it's the same for both. I don't say instance 1 equals instance 2 equals 7. But the interpreter is clever enough to say, hey, it's the same that I already have. So let's reuse it. So to sum up a bit, every object has an identity, a type, and a value. Identity and type are unchangeable. You can manage to change the type, but you shouldn't do it. So try to not do it, and it's quite difficult to do it. With the function ID, you can check the ID of an object. With type, you can retrieve the type. But remember to be Pythonic. Don't check the type of your objects, of your arguments everywhere in your code. Avoid it, please. I only use type when I'm debugging and I'm not sure that I'm receiving exactly what I expected, and only in the debugger and very special cases, okay? So also, you can use is operator to compare the ID of two objects. As we have seen, Python reuses some objects. So they bind them to different labels. So you can think that you have two objects, but no, you have exactly the same object here, here, and even here. When I write 7, to interpret this sentence, Python has to create another object here in the right side. And this is again another object, but it's a label pointing to the same previous int with value 7, okay? Yeah. Double equal 2 equals is to check the value, and is to check the ID. So when I really use it is when I compare with known. Something is known, null. Okay, it's when you really use it. Let's do the same with lists. And what happened here? It failed, right? So exactly the same example that I had with ints, with lists, fails. Anybody knows why? Yeah, that's it. That's it. That's it. Numbers are immutable, so they won't change. Its value won't change, and lists are mutable. This means that a list can be changed. We can do in-place modifications, and the object is the same, its address is the same, but the content of the list has changed.
So you want your render too much.
Hello?
Now it's working.
Hello? Yeah.
Okay.
So, good.
Sorry for the inconvenience.
Yeah, if I go down again, please let me know.
Sure.
Okay, so yes, that's it. Lists are mutable. So we cannot reuse lists. Well, the interpreter cannot reuse lists because maybe you change its content and then you were pointing to a wrong object. Okay, do you understand it? Let's see more examples. Two booleans. Okay, both are true. And when we compare the RD, they are exactly the same again. With known, let's try with known, and it's exactly the same. Known is a constant, and it's the only accepted value of known type. Okay, so it's a type, and it's a value. Yeah. And again, the ID is exactly the same when we compare an object with value known and another one with value known. However, with lists, it fails because they are mutable, okay? And this is it. What objects are mutable? Well, in the standard library, maybe the main ones are digs, lists, also sets, and then in collections module you have ordered dig and some other beautiful stuff, okay? What are immutable? What objects values, its value cannot be changed? Well, we have numbers, strings, tuples, known type, so on, okay? But those are the main ones. As I said, mutables allow in-place modification, and that's why we cannot reuse them. And mutables are reused by the interpreter. He's not super clever, and he's not able to reuse absolutely everything, as we will see, okay? But let's try with a list with 5 ints with value 7. And as you can see, all of them have the same ID. And it's exactly the same ID that we had previously here. Well, it's super long, but 21368, and it ends with 21368, right? With the strings, exactly the same. It reuses. With empty tuples, exactly the same. Empty lists, it fails. Well, it fails. It creates a new object each time. What we have here is a list with 3 indexes in this case, and each one is pointing to a different object, okay? With dictionaries, the idea is different. And if we have tuples with certain content, it also fails. As I said, it's not possible to take all the objects and loop inside them, looking all its content to check if you already have this object created. So there is a limitation, obviously, okay? Let's go to a website. Oops, sorry. Oof. Can you read this? More or less, maybe, as I try to increase. Better? So it's called Python Tutor, and I love it because it's really, really easy to see it. You can type your code here, then visualize execution. Oops, it will be a bit hard to see it. Okay, let's try. Forward. And as you can see, we create a string, we create another string, and both are pointing to the same value, as I said. With ints, it happens exactly the same, okay? And another example, it's the same code that we saw, but an image is worth 1,000 words, right? And bools, known, and as you can see, lists are created. Okay, so I guess this part is clear. Let's continue. As I said, we can change, you may think, okay, but I can change the value of a string. No, you are not changing the value of the string. Look, I create a string, and I change its value, but I'm not changing its value. I'm binding the same label to a new object. So you are not really changing its value. You have the equals here, okay? It's important to understand this. And then its ID changes, obviously. Yeah, you have created a new object and you are pointing to this new object. Also the name, the label is exactly the same. However, with a list, you have operations to modify the list in place. So you have exactly the same ID pointing to the same object always, but the content of the object changes. Let's try something different with dictionaries. We have a dictionary. We use a tuple as the key of the dictionary. Quite easy. But if we try to use a list, it fails. Why? Because of the same thing. Lists are mutable, they are not stable, so they cannot be used as keys of a dictionary. Because they can be changed, then it will be a mess. What happens if I take this list later and I add a new integer inside the list? The dictionary hashed a list and then hash an object and then it's a different object. So you cannot hash them and you cannot use them as keys of dictionaries. So what happens here is that if you're not aware of the behavior of mutables and immutables, so at the end you can think, okay, it's like I have all the objects as a with a reference, like other languages. You have pointers. So it's hidden, but it's what is happening as we have seen. But you can change sometimes the content of the pointer, or you can change sometimes where it's pointing. And maybe it leads to some errors. This is a recopilatory of some errors that I have seen or I made in my life with Python. Okay, for instance, multiple assignment. We assign multiple ints. What's happening here? We have two ints pointing to the same object, right? As we did previously. Both have the same address. When we change one, we are assigning, so one of the ints is pointing to a new address, to a new object, okay? What happens with lists? we have two lists. We created them with multiple assignment. We modify one of them. What will happen to the other list?
Changes.
Yeah, it changes. That's it. It changes because it's the same list. Different levels, but the same object.
It's like another door to the same room.
Yeah. Yeah, but you are changing the same object. So you have to take care. You have to take care with this because maybe you are not aware that you are modifying something that shouldn't be modified. And exactly the same happens if I create a list and then I create a new label pointing to the same object. It's the same that multiple assignment, or it's the same that we saw previously. So great. So it's exactly the same, and what's happening is that you are modifying the same object. Somebody could think, okay, but here I'm copying the object. No, you are not copying the object. You are just pointing to the same object. So the new list is changed. What this for loop does is that it modifies in place all the content of the list with power of 2, okay? It puts the power of 2 of the previous value. But what happens to the initial list? The initial list is changed also. So you could think, hey, I copied it here. No, you didn't. No, you didn't. You only copied the pointer. You only said, okay, I point to the same object that this other label. And exactly the same happens with a constructor by copy, because it does shallow copy, not deep copy. So it only copies the references, the pointers. Okay. I have a dictionary. I create a new one using the constructor, which can copy another dictionary. But what it only does is it takes the same keys and a pointer to the same values. So in this loop, I modified the keys and I put them in uppercase. So as you can see, the new dictionary has the keys in uppercase and the old one in lowercase. Okay, that's good, right? We didn't change the keys of the original dictionary, the first dictionary. However, what happens if I try to change the list of one of the keys in one of the dictionaries? It will fail because it's exactly the same list in both cases. I append 7 to one of the values in the upper dict, and yeah, it changed. Again, it's the same problem, okay? How you can solve it? Well, avoid multiple assignment, unless you really want multiple assignment, unless you really want two labels pointing to the same object. And then you can use what it's called deep copy. Inside the standard library module called copy, you have the method deep copy, which really takes an object and loops this object, looks inside it, and really creates new objects with its content. Okay, more possible errors. We create a class. Yeah, pretty easy. A class, it has two class attributes. It has an int and it has a list. I create two instances of the class. I modify the int and the list of one of the instances. What will happen in the other instance? What will happen to the other instance? To the list and the int of the other instance? Yeah?
It should be nothing. It should be like when you first instance the class.
It should be nothing. Well, we will see. Let's see, okay?
I think that the address will be the same and the contents will be changed.
Yeah. And this is what happened. So, hello, I'm still here, maybe.
Sorry, from where I can download that examples file is possible?
If you go to the page of the training inside the EuroPython page, you go to the schedule and there you will see this training. You click on the training, it opens its page and there is a description and there is a link to GitHub. It's in GitHub. Or I have here in a memory pen if you want, as you wish.
Okay, I will try to download.
Okay, yeah, we will do an exercise in short and you should have the code downloaded, okay, for the ones that arrive later. Try to download the code because there are 3 exercises and we will do these exercises. And the first one is in short, okay, about this extra stuff, okay.
If you want to tell them, you have to click on the name of the training.
Yeah, if you go to the schedule, click on the name of the training. So it opens a pop-up when you click the first time, and then you have to click on the name of the training in the pop-up. And then it takes you to the page. Yeah, and there you will see the description, and you will see a link to GitHub, okay? And there you can download. But if you want, I have the code here, okay?
It's right below your name. Is the name of the speaker below a link to.
Yeah, below the name when you have the pop-up of the talk of the training. Okay, so what happened here? Do you understand what happened? Well, you can see what happened, but you understand why it happened?
Still the same object for both instances.
Still the same object, you mean the list, right? So the list is still the same object for both. Both are accessing the same list. Maybe here the problem is not with mutables and immutables. Maybe here the problem is how class attributes work in Python, okay? What happened is that I modified the class attribute, a list. I did an in-place modification with extend in one instance of the class, and the list was changed in the other, because obviously it's the same list for all of them. Yeah, it's the same list for both of them. So maybe you would expect to have a new list for each instance, and no, this is not what's happening. It's the same list for all of the instances. Actually, there is only one list, and the list is declared in the class. So class attributes in Python are stored in the class, not in the instances. It's important to understand how it works. Yeah, sorry. Sorry? Why? Could you repeat the question, sorry? Why the integer did not change? Because I didn't change the integer. Let's go back to the example. Yeah, maybe here. I assigned it to a new value. So when I assign it, where is stored this new value? This new value is stored in the instance, not in the class. When you modify the values, they are stored in the instance, not in the class. Okay? And this is what's happening here. While the list is kept in the class, and I'm modifying the same object, with the int, I'm doing an assignment. Okay? So when you modify a class attribute, when you reassign it to a new value, to a new object, this assignment is stored in the instance, not in the class.
If you had created the list, the value in an init method,
Yeah,
it would be different.
that's the solution to this problem. That's the solution to this problem. If you need a list, a different list for each instance, you have to create the list in the underscore init method. That's why there is this method, okay? Because if you do this way, you are sharing the content of the list across all your instances. Maybe it's what you want. So maybe this is useful for you. You can say, okay, it's great because I can share a kind of a state between all my instances. It's great, but maybe you didn't expect to change its value for all the instances, and then suddenly you start having really strange bugs, okay? Actually, if we check if you check the class, the value of the int remains the same because we have not changed it. We only change in one instance, and we change with the equal. So we assigned it to a new value. Right? Good. More problems or weird stuff. Okay. Yeah, this is a clue. Okay. Class arguments are stored in the class and created on import time. So this list, the instance of the list class is created once. When? When the interpreter took this code and created a class. And when it created a class, it created also an int with value 0 and an empty list. And it left both objects as class attributes inside the class. Okay? So also, another common problem I have seen with this kind of things is with dates. Somebody comes here and puts datetime.now, which should be now. And you expect it to create the date when you create an instance, and no. The date is the date when the interpreter created the class. So when this module was imported and when I wrote it in the console, okay? More examples. In this case, we have a list as default value of an argument of a function, okay? This function takes a value and appends to the list the power of 2 of this value, okay? Quite easy. And if we don't get a list, we take a new list, which is the argument that we are getting. So can you imagine what is going to happen with this list? Yeah, it's going to be one list. Why? Because it's the same that with the classes. The interpreter takes these statements and says, okay, I have to create a function. The function has a default value. Okay, default value is an empty list. Okay, I create an empty list and I store it inside the function. And this list, even before I executed the function for first time, the list already exists. So I execute for first time my function, and okay, I get a list with single item, which is the power of 2 of this value. Good. I do it again. What's going to happen? What's the content of result 2? Yeah, 2 items. What 2 items? 4 and 9, yeah. And this is what happened. And what's the content of result 1, which is the worst part of the thing? Result 1 is also 4 and 9. Because result 1 is a pointer to the same previous list. And in a magic way, you modified the result that you already got a few time ago. And maybe you implement a test and you say, hey, it works. And then the next test fails and says, okay, hey. And if you look, you say, how is it possible that the previous test didn't detect that I was adding all this stuff to the list? I did a test and it worked fine. But the thing is that you have later modified the list. You have modified its content because you weren't aware that it was exactly the same object always. Okay? Understood? Yes? Questions? No? How do you fix it?
Yes.
It's easy. Instead of an empty list of default value, put known. And then you create the list inside the function. And you will create a list each time the function is called, which is what you wanted. You wanted to create a list each time the function was called, and the second argument was not provided. But you didn't tell Python to do it. You told Python to create a list and have this list here. So again, if you want, you can have a kind of shared state across the results of, but well, it's pretty weird if somebody has to look at your code and you are using it as your business logic. Well, come on.
Can you use that same function, but you pass the keyword argument from a list with your own?
If you provide an empty list, it goes fine. We can try it.
So the message is just saying that it's a bad idea to put lists in default values.
Not just lists, mutables.
Any mutable.
Yeah, mutables. The same happens with a dictionary, okay? I use always list because maybe it's the most easy and mutable type, okay? And the same happens if you create an instance of any of your objects of your business logic. Okay, so if you create a class and you create an instance as default value, this instance is created only once. Only once. Okay, and again, it happens at import time. So what I saw once is that they had here, again, the example of the date. They had here, we were in a code review and somebody put datetime.now. And when you run the test, it works. Yeah, sure, it works. But no, actually it was not datetime, it was just the day, the date. So unless the code started at before midnight and it changed it to another day, it did not fail. But the day that it failed, it was like, what's happening? It's impossible to fail because it's taking the date and the date is wrong and it was failing. And it was because of it, okay? So as you can see, if we provide an empty list, it works fine. Okay, so the thing is when you try to reuse a list that you provided, because actually a single list each time, it's always the same list. Okay.
Sorry, I have a
Yeah.
question, but maybe that I misunderstood what you said.
Yeah. Go ahead.
If one of the arguments have a default value and that default value is a list, a null list, an empty list, then each time that you call the function, that empty list is not created again.
Yes.
It's the same.
It's the same list. The list is created only once. Let's do it. Let's do it. Look. And not only...
is created when you define the function?
Yeah, look, I create a function. This is a simple one, okay? I receive a list, and it has as a default value a list with 1 and 2, not just empty, any kind of mutable, and it's the same problem. When we check my func.defaults, it's already here.
I thought before that that default value is created at runtime, not at definition time.
Yeah. Well, it's created at runtime, but the first time that it reads the definitions. So if you have a function like this one in a module and you import that module, when you import that module is when, for first time, is when the list is created. And as you can see, as you may know, in Python everything is an object. And in this case, if we look at the object of the function, you can check the default values, and you can see that we already have here a list.
Okay, thank you.
You're welcome. So, more questions? No? This is it. Functions, default values are stored in the function object and created on import time. Okay? So there are still more common errors. In this case, is maybe a bit strange function, but what it does is that it receives a list, and I want to return the element in the middle of the list, okay? The middle index. But the thing is that I did it with a pop. Pop modifies the list, removing the index that I ask it to remove and returns it at the same time. So I'm modifying the list. Okay, the implementation is maybe even stupid, okay, but it's for the example. I create a list of 5 items. I provide the list to the function works fine, but what happened to the original list? Yeah, it's shorter. And why is shorter? An element is missing. Which one? The 3. That's it. What's happening here? The thing is that you are providing a reference also to the function. The function is taking the reference, and the reference is pointing exactly to the same object. And you are doing an in-place modification of the same mutable object. So if you have used, if you program with C or C++, you may be used to reference, and it's exactly the same. But it happens always, okay? Because if I provided an int, and I changed the int, I wouldn't be changing the int object. What I would be is, I would be assigning it to a new value inside the function. But with sets, lists, digs, you are changing it. So sometimes it's useful for you. So maybe you can have a set of functions which modify lists, and instead of calling the function with a list and retrieving the return value, you can just don't return anything and modify the function inside modify the list, sorry, inside your function. And it's good if you want to work this way. But you have to understand what you're doing, and you have to be aware, okay? Any questions with this last example? I think it's the last one. Yeah. So time to start working. Time to practice what we have seen now. If you downloaded the code, there is a folder called exercises, and inside you have exercise 1. Okay, I think I have it here. Yes. So inside objects, there is exercises and exercise 1. You have exercise 1.py, solution 1.py, and test 1.py. If you have nose test, okay, you have nose, you just execute nose test minus sv, and it fails. You have to solve the 3 tests, okay? Well, there are a few more, but now 3 are failing. So those exercises are about the common problems that we have seen right now about mutables and immutables. So try to figure out how to solve each of the problems that we have seen. I have told you the solution for some of them. If you need the code, I have it here. You need the code? Okay.
I'm on GitHub. Is it easy to download it?
Sorry?
Can I just download it from here?
Yeah, go back. Go to objects. Good. And here you can download zip.
Okay.
Clone or download zip,
Oh, good. Thank you.
as you wish. Okay?
What is the exercise? I have the code, and then I have to try to find a bug in the program.
Yeah, there are, well, 3 bugs,
What?
which are exactly what we have seen now. So the idea is that you try to solve these common errors with mutables and immutables that we have seen now. More or less are exactly the same examples. Well,
So we have about 40 minutes.
good.
For the break and the training section, we have some sort of elasticity. We are not as strict because you have not to leave the room for the next speaker. You're still the next speaker.
Okay, good,
It's fine for us.
good.
So if you want to take minutes before, 10 minutes after, not an issue with us.
Okay, thanks. If you have any doubt, I'm here, so don't hesitate to ask me or whatever.
Try talking to see.
Hello, hello.
Okay, it works.
Yeah.
Okay, they told me to make a check. L'audio o check? No, si era spostato lui avanti. Se vuoi dire, è il momento dell'esercitazione che dovrebbe proseguire fino al coffee break, se vuoi usare come... Ok.
abbastanza rendire il momento dell'esercitazione, poi si va fino al computer.
And nose tests. And you have to go to the exercises folder
Exercise.
because
Okay, I want to just.
see the exercises, exercise one.
Okay.
One. Yeah, here. Nose test. And put, yeah, that's it. Good. You're welcome.
Nice exercises. I
Good.
think they are very simple enough and complex enough to incur in common troubles. So,
You already saw them?
one.
Okay,
He
good.
called me for a technical
Oh,
figure.
good, good.
Very easy. You simply have to
Yeah,
get two different.
yeah, they are quite easy, but well, 5 minutes remaining. How are you doing? Maybe, okay.
Question. I've got it working, but how?
Let's see, raise your hand if you have finished. Okay, more or less 50%. Okay, I leave 2 more minutes, okay? And let's see the solution. Okay, so again, let's raise your hand if we have if you have finished. More people. Okay, let's go ahead. So, first example, what's the problem? A volunteer, somebody? Yeah?
You're assigning even odds to the same list.
Yes. We have the multiple assignment, so it's the same object as we saw in the first example. So it returns exactly the same in both cases. It's wrong. Solution, well, maybe the easiest one is create two empty lists and problem solved. Okay? Pretty easy, this one. Yes? Any other solutions here? No? Okay. The next one. Class attributes. We modify, yeah. Do we have the microphone? Yeah, maybe this. Sorry, I can't hear you.
The solution about the second test? Second test?
The solution about the second test? So what?
That's why I raised my hand. Sorry, I don't know if I interrupted you or something.
No, I meant if you had a different solution.
No, for the first one, no.
No, okay, so let's go to the second one. Okay? Yeah.
Different solution would be even, odd, equal, even. Sorry. Another possible solution for the one. Odd, equal, even, open, and double point close.
Yeah, that's actually what Giacomo did also. And what you are doing this way is copy the list using slicing. But when you are copying using slicing, you create a new object. Okay, it works here, but there are two things. One, it's a shallow copy. So if your list contains mutable objects, you only copy the reference to that object. So if you expected to copy recursively a list, you are not doing it. Okay? And in addition, you know it's an empty list. So maybe it's easier to just create another empty list because you already know. If you had to copy a list because it's an input argument, maybe it's a solution. But remember the thing of the shallow copy, which is one of the problems that we saw. Okay? Thank you.
So in few words, it works, but it's not the better solution.
I think it's not the better. So it works in this case, but you know it's empty. So maybe it's easier to create a new list. And in addition, it's a shallow copy. So take care also. More alternative solutions? Okay. So let's go ahead with the second one. In the second one, we had two class attributes. Both are lists, so both are mutables. Remember that the same happens with sets or digs. I only use lists because maybe it's easier to work with lists and it's more familiar maybe with people. Okay, so what happens? I create two instances of my numbers list class, and the thing is that I only modify the lists. So I only modify the content of the first instance, of instance A, but when we check the second instance, we have modified also the list. So as we saw, we are reusing the same list. How would you solve it? How have you solved it?
Creating them in the constructor. Creating them in the constructor.
Creating them in the constructor. Well, creating them in the init, right? In the underscore init. Actually, as we will see later, this is not the constructor. It's the initialization of the instance. Okay, but yes, this is the best solution. So you need a new list, well, in this case, 2 new lists for each instance. Then you have to really create 2 new lists each time the instance is created. You can do it in the init, in the underscore init, okay? And this is how I solved it. Actually, most probably you don't need these 2 lines. Okay, so most probably you can skip them. Maybe you need them because you need another function to know if it's initialized or not or whatever. But most probably you don't need this class attributes. Okay, and you can go directly to the underscore init and create here inside the instance 2 new lists. Okay, and then it works. We append and we check the other instance, and the other instance hasn't been modified yet. Any other alternative solutions? Okay. Yes?
You initialize even and odd in the constructor, in the init function.
Yeah.
Do you need to initialize even and odd with none? Is mandatory?
No, you mean this line and this line?
These 2 lines.
No, it's what I said.
Not
You don't need.
right?
No, you don't need them. You don't need them.
Is enough to initialize
Yeah.
in the constructor?
You can remove both lines and directly create the new lists each time that you create an instance.
Okay.
Okay? So again, in this case, what was the problem? The problem was that we were providing the list, the empty list, as default value, and we expected to be new lists each time the function was called. And each time you call the function, you are reusing the same list, so the results are quite strange. You are accumulating everything for each call, okay? That's a problem. Well, that's what I did not expect, okay? Solution, you can change and do even equals known, odd equals known, and then inside the function you check. If you're not getting a list, then you can create a new one. Check this. We're using is. Remember what was is? To check the identity. In this case is what we want, because we want to check that this object, this label, even, and this label odd are pointing to known, to the object, to the null value, okay? And this is the typical place where you use is. Here, somebody asked if there was a more polite or more beautiful solution instead of using if, even, and these 2 if constructions. Okay, you can use a Boolean condition and do something like okay. But well, I wanted you to show. This is really the only case where I use is to compare with known. And it's a recommended way to check if an object, if a label, actually, as you have seen, is null. There were some questions. Yes. Oops. Well, in the meanwhile.
Yeah. Why not equals and why is? I mean, it's
Equals known. Well, this is the recommended way. It works also, but it's supposed to be more effective this way.
more effective in what?
It's a 50% faster according to stack trace and not with that.
Okay.
Yeah. So as they said here, it's a 50% faster. Really? So much?
Yeah, I'd say 50 in stack trace. I can send you back.
Good. Good.
In Pet 8 is the very nice clear explanation.
Sorry.
In Pet 8, it's very
In PEP 8?
Yeah,
Really?
yeah.
Okay, so let's check PEP 8 and let's check the explanation. But it's a recommended way. I don't know, it's something I learned, and it's the only case where I really use is. Okay. There was another question. It's answered? Okay, good. More questions, more alternative solutions? No?
I think that the main reason you use is to compare anything to none is that if you do equals equals, you are comparing two values.
Yeah.
Instead, if you are using is, you don't know what the first object is. You just compare it to none. If it is none, okay.
Yeah,
So you skip a step.
Yeah, that's it. So as we saw at the beginning, is compares the ID. So most probably it's faster to check the ID of two objects instead of going to check its value, because you have to take the address, go where the value is stored, and then take the value to compare. So, well, I thought it wasn't so much, like 50%, but it's good to know. Okay, so let's continue then. And the new solution works fine, okay? So the training is split in 4 modules, and we have finished the first one. If you have downloaded the code, you will see that they have placed at the end of each module, there are some links. You have here the Python tutor that we saw previously. I think it's quite a good way to understand this kind of things, okay, and in a visual way. And there are other links. You have here the link to the deep copy that we talked previously. Actually, I forgot. Yeah, there is a resume of what we have been seeing. Okay, so multiple assignments. How we solve the problems with multiple assignments? Avoid it. You can't do multiple assignment of mutable objects unless you really want to have two labels, two names pointing to the same object. Problems with shallow copy, constructor by copy, this kind of things. Use copy.deepcopy of a standard library, and then it will really take the object, take its content, and create new objects for the mutables, okay? Class attributes, how to solve the problems with mutables, sharing, let's say sharing their state across all instances. If you don't want it, you have to create the mutable values, the mutable attributes inside the underscore init. About default value, use known and create the object also inside the function, more or less the same that in the class. Okay, and I didn't add an exercise for this one, but in place modification of functions mutable arguments, what we saw that you receive a list, you change the list inside the function, but you didn't expect the list to change outside. There is no solution here, so either you copy with a deep copy the list or the mutable object each time the mutable argument inside the function, or be aware of what you are doing and don't modify your input arguments if you are not expected to do it, okay? So here you have the references, okay? Most of the stuff that we're gonna see today is this site in the standard library reference. I think I have it open here, yeah. Maybe it's difficult to see it, but here you have the explanation of ID, of the type. You have everything, almost everything that we're gonna see today here. Yeah, we have seen more or less this part, and now we're gonna see this other part. Okay, next module. New style classes, old style classes, why, and differences, and data model and customization of your objects, okay? The break is in a few minutes, so we will start seeing the new style and old style, and we'll go to have coffee and fresh air. So, I create a class. Pretty easy, right? I have my class, I have a function, the function prints the type of self, so the type of the instance of the class, and this underscore underscore class attribute, okay? And this is what happens. I created an instance and I call this method. And what we got? We got that type is instance. Instance. Pretty weird. And yeah, the underscore underscore class, it says that it's my old class, so the class I created. This is happening because this is an old style class. Let's do it again, a bit different. In this case, we are inheriting from object. Right? And the implementation is exactly the same. Nothing has changed. You can compare here and here. It's exactly the same. Okay? And now we call the function, and the output seems quite better, at least more coherent. Okay? The type is not instance. Come on, what's instance? Yes? No. Sorry. So,
Sorry.
yes.
I see that what you call the old style class definition does not receive any argument, and in the new style it receives an argument of name object.
Yeah.
Then what is the difference between both?
You are inheriting. This is, here you are inheriting from object. And here you are not inheriting from object.
The inheritance is defined in that way?
Yeah, inheritance is defined in this way. And here you can put a list, a comma-separated list of classes, which will be your superclasses.
Okay.
Your ancestors, okay? So, in the first example, I'm not inheriting from anything. And I can skip even the parentheses, okay? The empty parentheses. And here, I'm inheriting from object.
There is a superclass like in Java that is object, and all the classes are inherited from it?
Well, here, in this example, I'm inheriting from object because I'm telling it to do it. And that's the difference. Here, the example, the idea is to understand the difference between one and the other. The first one is what is called old style class. And the second one is a new style class. Okay, and here I have a bit of theory of what's each of them. Okay, so
I have another question.
Yeah.
I'm sorry. There is no a constructor definition.
now you
Then
can.
there is a default constructor like in C++.
The thing is that the underscore init, it's not really the constructor. It's the method to initialize an instance. Init receives an instance already created, but you have to, so you use init just to fill the instance, to initialize its content, but not to create. And yes, there is a creator by default, and there is an init. Well, by default, there is no init because you have not to fill anything inside the class, inside each instance of the class. So you can skip it if you want.
But actually for the programmer, the init is the constructor, right?
Yes, we will see a bit of this later. We will see differences between the underscore new and underscore init. Okay?
Okay. Thank you very much.
You're welcome. So, new style classes were introduced in Python 2.2. Well, with Python 2.2, okay? And the idea was to unify classes and types. Up to then, they were not unified, and we had things like this one could happen because an instance of a class was of type instance, and that's it, and was not of the type of the class that you had implemented, okay? And it was pretty weird. So this is one of the changes introduced in Python 2.2. The idea was to provide a unified object model with full meta model. You have all the documentation here. I think that this post was written by Guido, but it's a really extensive post explaining everything, and I think it's quite interesting reading it. Okay, but I have tried to summarize the important things here. Okay, other benefits that provide the new style classes: you can subclass most of the built-in types. Until Python 2.2, it was not possible to create a subclass of dictionary or list to customize its behavior, or even floats or ints. It was not possible, right? And with this change, it became possible. Also, the scriptors were introduced, and thanks to the scriptors, we have slots, properties, and even static and class methods. So prior to Python 2.2, we did not have all this stuff. So it's a really important release in Python, okay? And the thing is that by default, all classes are old style in Python 2, while in Python 3, all the classes are new style. Okay? Yeah. The thing is that to keep backwards compatibility, it was not possible to switch directly and say, okay, from now on, everything is new style. No, because there were things that didn't work fine. Okay, so that's why new style classes was introduced. But you have to inherit from object. You have to do it yourself in order to have new style classes in Python. And when you have to do it, you have to do it always. Try to do it always, because you get a lot of benefits with new style classes, and you don't get any benefit with old style. So each time that you implement a class, don't forget to put the object as your ancestor, and it's here. Remember to inherit from object, or you can inherit from another new style class, and then your class will be also new style class. Okay? It's important because you get a lot of benefits. Sometimes I have seen people say, okay, it's just a class to store 2 values and I won't do anything with it, but then maybe 1 year later you have to do a refactor and you have to add more stuff, or you have to subclass this stupid simple class, and then you have a problem because it's an old style class, and you have to go and change also the implementation of the class. So do it directly and you will get only benefits and no drawbacks. Yeah, this is it. You must avoid old style. Get clear. In Python 2.2, there were other changes introduced, like __new, the behavior of the dir function, meta classes, method resolution order, and more or less in the continuation of the training, we will see more or less all of this stuff. But I think now it's time for the break, right? So
now, before leaving you to a well-deserved break, I have to remember you that you can vote this training if you go on our site, EuroPython.eu. You click on a mobile guide, you can download the guidebook and give a rating to our speaker. I think a good rating should go.
Thank you.
I learned something already, so
good to know.
Another thing, I remember you all this evening at starting at 9 p.m. We have to have fun and learn even more with Google Code Jam. If you are interested, even a beginner can still learn and try his hand with this test. So now break and vote. Okay.
Thank you. See you in half an hour?
Yeah. There is about half an hour break or so, okay?
Good.